Welcome back to Science to Sleep By. As you settle in, let your breathing slow and your mind drift into the rhythm of the cosmos. Tonight, we're taking a quiet journey beyond the familiar boundaries of our solar system. You've looked up at the night sky before, maybe from your backyard, or perhaps on a camping trip under the stars. But have you ever wondered what lies above our solar system, and what stretches out below it? Together, in this gentle voyage, we'll explore not just the planets and stars we know, but the grand architecture of space itself. So close your eyes, relax, and let science guide you softly into sleep. When we think about the solar system, it is easy to picture the planets circling the sun, the moon rising and setting, and perhaps even the faint ring of comets and asteroids that extend far into the outer reaches of space. This picture feels complete, almost self-contained, like a family portrait framed against a dark background. But the truth is that our solar system is not an isolated bubble floating in nothingness. It is part of something far larger, something so vast that even the most powerful imaginations struggle to comprehend it: the Milky Way galaxy. To understand what lies above and below our solar system, we first need to understand our position within this immense cosmic structure, because only then can we place ourselves in the wider map of the universe. The Milky Way is a barred spiral galaxy, a collection of about 200 to 400 billion stars, interstellar clouds of gas and dust, dark matter, and mysterious structures we are only beginning to detect. Our galaxy is shaped like a disk, flattened and rotating, with long spiral arms that curl outward like the swirling patterns of cream in coffee. At its heart lies a dense, bright core, a bulge of stars that surrounds a supermassive black hole known as Sagittarius A. Around this glowing core, the arms stretch and spiral, filled with the building blocks of stars, planets, and life itself. This entire system spans roughly 100,000 light-years across. To travel from one end of it to the other, even at the speed of light, would take longer than the whole of recorded human history many times over. And within this colossal structure, our solar system is tucked away, quiet and unassuming. On the edge of one of the spiral arms, the Orion arm, sometimes called the Orion Spur, our position is not at the center of the galaxy, nor at its edges, but somewhere between. The Sun and its planets orbit the galactic center at an average distance of about 27,000 light-years. Imagine it: our Sun, blazing bright enough to give life to Earth, is just one small star among billions, circling around the galactic core as if it were a grain of dust in a great, cosmic carousel. The speed at which we move is astonishing. The solar system travels at nearly 500,000 miles per hour as it loops around the galaxy. Even so, a single trip around the Milky Way, a galactic year, takes about 225 to 250 million Earth years. In the time since the dinosaurs walked the Earth, our solar system has only completed one galactic orbit. This perspective humbles us. It shows how brief human time has been compared to the rhythm of the stars. When we describe our place in the galaxy, it helps to visualize the disk-like structure of the Milky Way. Think of a record spinning on a turntable. The dense lanes of stars, gas, and dust form the flat part of the record, and our solar system lies within that flattened disk, slightly tilted in its orbit. Astronomers sometimes speak of the galactic plane, which is the imaginary sheet that slices through the middle of this disk. From our position, we are not exactly centered in that plane, but a little above or below it, bobbing gently as we orbit, like a boat drifting on cosmic waves. Over millions of years, the solar system rises above the galactic plane and then sinks below it, oscillating slowly as it makes its way around the galaxy. This subtle movement means that even our position relative to the flatness of the Milky Way is always changing. In addition to this movement within the galaxy, we are also part of a much smaller neighborhood known as the local bubble. This is a region of hot, low-density gas, a sort of cavity carved out in the interstellar medium, likely created by supernova explosions millions of years ago. Our Sun, along with nearby stars such as Alpha Centauri, Sirius, and Procyon, all drift within this bubble. Imagine our solar system floating in a pocket of space swept clean by ancient cosmic events, protected in some sense by this bubble's relative emptiness. This neighborhood is one more layer of our cosmic address, a reminder that we are not only part of the galaxy as a whole, but also part of a smaller, more intimate region shaped by the life cycles of stars. Another important aspect of our place in the galaxy is our relationship with the other structures around us. To one side, closer to the galactic center, lies the dense Sagittarius arm, filled with clusters of stars and nebulae. To the other side, toward the galactic edge, is the Perseus arm, a larger and brighter spiral arm. We sit in between, in a quieter spur, like a side street branching off from a main highway. This location has turned out to be quite favorable for life. If our solar system were located deeper within the galactic core, the density of stars and the frequency of cataclysmic events like supernova might have made life, as we know it, impossible. Out on the edge, far from the star-rich arms, the supply of heavy elements needed to form rocky planets might have been scarce. But here, the Orion arm, conditions have been just right. The sun was born from the remnants of earlier generations of stars, enriched with the heavy elements necessary to build Earth, water, and organic molecules. It is in this sense that our place in the galaxy has shaped the very possibility of our existence. When you step outside at night in the United States, whether on a summer camping trip in Montana, a desert evening in Arizona, or a quiet backyard in New England, and you look up at the silvery band of the Milky Way stretched across the sky, you are seeing the disk of our galaxy edge on. That faint cloud of light is not a cloud at all, but the combined glow of billions of distant stars, packed so tightly along our line of sight that they blend into a river of light. From our vantage point inside the disk, we cannot step back to see the spiral arms in their full glory the way we can see other galaxies through telescopes. Instead, we are immersed in the structure itself, swimming through the light of our galactic home. This view is both limiting and profound. It means we can never truly see the Milky Way from the outside. Yet it also means we are part of the mystery. Looking outward from within, astronomers use these observations to continually refine our sense of place. With radio telescopes, we trace the distribution of hydrogen gas, which outlines the spiral arms. With surveys of star positions, like those produced by the Gaia spacecraft, we map the three-dimensional layout of nearby stars with unprecedented precision. Each new measurement adds detail to our cosmic address, placing the solar system more firmly within the grand framework of the galaxy. It is as if humanity is slowly filling in the lines of a map, not of continents or oceans, but of the galaxy itself. And yet, despite all this knowledge, our place in the galaxy still carries an air of mystery. We know the broad strokes. We orbit the galactic center. We rest in the Orion arm. We drift inside the local bubble. But what lies beyond? What shapes and forces define the galaxy's outer regions? And how our solar system fits into the larger web of the universe? These are questions that continue to push the boundaries of science and imagination. When we speak of what is above the solar system, it is important to pause and recognize that these directions are not like the ones we use on Earth. On our planet, above means skyward, below means groundward, and the compass points are rooted in the shape and spin of Earth itself. But in space, there is no up or down in any absolute sense. Instead, astronomers create frames of reference. For our solar system, the most useful one is the galactic plane, the flat, disc-like sheet that defines the shape of the Milky Way. To say something lies above the solar system means that it is situated on one side of this plane, looking outward toward the denser regions of stars that stretch across the galaxy. To place our imagination in this orientation, think of the Milky Way as a great cosmic pancake, and our solar system as a tiny seed embedded in that pancake. When you imagine lifting your gaze upward from the pancake surface, you begin to explore what lies above us. Above the solar system lies the heart of the galactic disk, that crowded, glittering lane of stars and nebulae visible on a clear night. For observers on Earth, the sky above is painted with the Milky Way's band, a soft, glowing ribbon of light stretching across the heavens. This is the visual evidence of the galactic plane itself. When we look toward this band, we are staring through the flattened disk of our galaxy edge on. Billions of stars, along with dark rivers of interstellar dust, lie superimposed along our line of sight. The light of distant suns overlaps and merges until it becomes a milky glow. This is one of the few places where human eyes can directly sense the structure of the galaxy we live in. For countless generations, long before telescopes, cultures all around the world gazed upon this hazy band and created myths to explain it. Rivers of milk from divine beings, pathways for souls, great celestial roads spanning heaven and earth. In modern astronomy, above the solar system is defined more precisely as the direction of the North Galactic Pole. This imaginary point in the sky, located in the constellation Coma Berenices, is the marker of above relative to the disk of the Milky Way. If you could leave the solar system and fly along this axis, you would be heading upward out of the disk, away from the galactic center line, and into the regions of deep space beyond. It is not marked by any single bright star, but it represents a window into the structure of the universe outside our galaxy. Observatories point their instruments here because it offers a clear line of sight beyond the clutter of the Milky Way's arms. Unlike directions that point us through the dense stellar neighborhoods, this vantage provides glimpses into the vast expanses of galaxies lying hundreds of millions of light years away. From this perspective above the solar system, the density of stars quickly diminishes. Within the galactic disk, stars are more crowded, gas and dust are thick, and clouds of interstellar matter weave through space like fog. But rising above the disk, we move into quieter territory. The further upward you go, the fewer stars you encounter, and the clearer the view becomes. Astronomers often compare it to climbing a mountain above a city's smog. Once you rise far enough, the haze clears, and the stars beyond come into sharp focus. This makes the northern galactic pole one of the cleanest windows for cosmology, the study of the universe as a whole. Telescopes have used this vantage to map distant galaxy clusters, to measure cosmic background radiation, and to study the large-scale structure of the cosmos itself. Yet even as the view clears, the concept of above reminds us of the dynamic way the solar system moves. Our sun, with all its planets, is not fixed in the galactic plane. Instead, it oscillates gently up and down through it as it orbits around the galaxy. Every few tens of millions of years, the solar system crosses the midline of the galactic plane, rises above it, then arcs downward again. The causes of this oscillation lie in the gravitational tug of the galactic disk, the pull of stars, gas, and dark matter working together like a cosmic tide. This vertical motion is subtle, but over vast timescales, it creates a rhythm. Some scientists have even speculated about connections between these oscillations and events on Earth, such as mass extinctions, though such ideas remain debated. What is certain is that our solar system is never fixed in one place. It is always moving, always shifting, always climbing above or falling below the galactic plane as it makes its long journey around the Milky Way. When you think of above the solar system, it is also worth considering the invisible. Our human eyes are tuned to visible light, but space is filled with radiation across the spectrum. Radio telescopes reveal wisps of hydrogen gas above the disk, tracing the skeletal arms of the galaxy. Infrared instruments pierce through the dust that hides stars from view, showing us the outlines of stellar nurseries and ancient clusters. X-ray telescopes detect the faint glow of hot plasma that fills the galactic halo above the disk, a reminder that even in regions that appear empty, energetic processes are at work. Above the solar system is not a void, but a layered, dynamic environment where gravity, radiation, and matter interact on scales far beyond our daily experience. Above us also lie the remnants of our galaxy's violent history. Evidence suggests that the Milky Way has consumed smaller galaxies over billions of years, and the traces of these ancient collisions are still visible. Streams of stars, torn from their original homes, arc above and below the galactic plane like faint scars, Some of these streams pass near the North Galactic Pole, reminders that our galaxy is not a static structure, but a living, evolving system. Each stream carries the story of a smaller galaxy swallowed by the Milky Way's gravity, each a relic of cosmic mergers that helped shape the galaxy we inhabit. Looking above the solar system is, in part, looking at the fossils of galactic history. Of the solar system, then, is both a direction and an idea. It is the path that leads out of the disk into clearer skies. It is the region where astronomers can see the universe beyond the Milky Way. It is a domain where the density of stars fades, where ancient streams of stellar debris cross the halo, and where hot gas stretches outward into intergalactic space. It is a reminder that we live not only within a galaxy, but also within a universe teeming with galaxies, each one as vast and complex as our own. To gaze above is to lift our perspective, to see past the familiar glow of the Milky Way and into the infinite tapestry of the cosmos. When we imagine directions in space, below, the solar system sounds like a simple opposite to above. But as with every attempt to map human ideas onto the cosmos, it requires us to think carefully about frames of reference. On Earth, below is the ground beneath our feet, the surface that anchors us. In the sky, we look upward to stars and galaxies. But in the broader structure of the Milky Way, below refers to the side of the galactic plane opposite the North Galactic Pole. If above carries us toward the constellation Coma Berenices, then below sends our vision into the direction of Sculptor. It is the southern galactic pole, a vantage that is less crowded, less obscured, and quieter in appearance, yet no less profound. To consider what lies below the solar system is to explore this cosmic underside, a perspective where the layers of our galaxy thin out and distant structures reveal themselves more clearly. When below the galactic plane, astronomers find a view that is markedly different from the one above. The Milky Way's disk is a crowded environment, packed with stars, gas clouds, dust lanes, and turbulent activity. It is like living in the center of a bustling city, where every direction is filled with lights and noise. But step outside of that city, descend into its outskirts, and the commotion fades. The stars grow fewer, the lanes of dust become sparse, and the overall view grows clearer. Below the solar system lies just such a cosmic neighborhood, where the distractions of the galactic plane fall away, and the universe beyond comes into sharper focus. The southern galactic pole, the direction astronomers use to define below, is one of the most useful windows for deep sky observation. In this part of the sky, telescopes can look outward without being blocked by the glowing band of the Milky Way. Instead of a crowded river of stars, the view is open and relatively empty, like standing on a quiet plateau with an unobstructed horizon. From this vantage, astronomers have identified galaxy clusters, cosmic filaments, and structures stretching across vast distances of the universe. The Sculptor constellation, which marks this direction, is home to the Sculptor group of galaxies, one of the closest groups beyond our own local group. These galaxies, faint smudges of light to the eye, but rich sources of data through telescopes, offer a glimpse into the way galaxies interact, evolve, and cluster together in the cosmic web. But below the solar system is not merely about external galaxies. It also reveals something about the structure of the Milky Way itself. The disk of the galaxy, where our solar system resides, is only about 1,000 light-years thick in most places. That sounds enormous from the human perspective, but compared to the 100,000 light-year diameter of the Milky Way, it is a thin sheet. Above and below this sheet lies the galactic halo, a much larger and more diffuse sphere of stars, globular clusters, and dark matter. When we direct our gaze below the disk, we are peering into this halo. Unlike the spiral arms or the galactic bulge, the halo is not a dense or easily visible structure. It is faint, scattered, and mysterious. Many of its stars are ancient, dating back to the earliest ages of the galaxy's formation. Globular clusters, tight spherical groups of hundreds of thousands of stars, hover in this space like lanterns suspended in the dark. Each one tells a story of an early chapter in the galaxy's life. When stars formed in dense bursts and gathered together into tightly bound systems that have survived for billions of years, the galactic underside also carries traces of the Milky Way's violent history. Over its lifetime, the galaxy has absorbed smaller galaxies, pulling them into its gravitational grip and stripping them of stars. These interactions leave behind tidal streams, long, faint ribbons of stars that arc through the halo above and below the plane. One well-known example is the Sagittarius stream, the remnant of a dwarf galaxy currently being consumed by the Milky Way. Parts of this stream pass below the galactic plane, crossing into the southern hemisphere of the sky. When astronomers study these streams, they are reading the fossil record of galactic cannibalism, evidence that the Milky Way has grown not only by forming stars within itself, but also by devouring its smaller neighbors. The space below our solar system also plays host to the vast and invisible presence of dark matter. While we cannot see it, we know it is there because of its gravitational effects. Dark matter surrounds the galaxy in a massive halo, extending far beyond the visible disk. It is this unseen structure that gives the Milky Way its gravitational glue, holding the stars, gas, and spiral arms together and shaping the motions of objects within. When astronomers measure the movements of stars below the plane, they are indirectly mapping the distribution of dark matter. These studies suggest that the bulk of the galaxy's mass lies not in the bright disk we can see, but in the invisible halo stretching far above and below. Thus, to look below the solar system is also to look into the unseen skeleton of the galaxy, the framework on which all else rests. What makes the underside so fascinating is its contrast with the disk itself. Within the galactic plane, the interstellar medium is dense with dust and gas, raw material for new stars. But below the plane, this density thins out. There are fewer molecular clouds, fewer stellar nurseries, and less obstruction for telescopes to peer through. This relative emptiness is why the southern galactic pole is such a valuable observational target. It provides a clear window for studying the cosmic microwave background, the faint afterglow of the Big Bang, which would otherwise be obscured by the brightness of the Milky Way. In this sense, below the solar system is not just a direction, but a keyhole into the origin and structure of the entire universe. And while the northern galactic pole points us toward the Coma cluster and other deep fields, the southern galactic pole offers its own treasures. The Sculptor group, lying below the plane, includes several nearby galaxies like NGC 253, also known as the Sculptor Galaxy. It is a starburst galaxy, actively forming stars at a rate far higher than the Milky Way. Through telescopes, it appears as a hazy oval streak, glowing with the light of billions of suns. To imagine such a galaxy lying below us is to recognize how alive the universe is, how different galaxies can be, and how our own Milky Way is only one among countless others, each with its own character and rhythm. The very concept of below, however, remains symbolic. Space has no universal up or down, only relative directions. To say something is below the solar system is, to use a human term, rooted in our experience of living on a planet with gravity pointing downward. But in space, below is simply one orientation defined by our galactic coordinates. And yet, this language matters. It grounds our imagination. It allows us to visualize ourselves not as drifting aimlessly in a void, but as anchored in a larger structure, with pathways above and below, vistas that can be explored, mapped, and understood. When astronomers speak of the North Galactic Pole, they are not referring to a physical object in space, but to a direction, a coordinate system that helps us orient ourselves within the Milky Way. Just as Earth has north and south poles defined by its axis of rotation, the galaxy has its own orientation. The galactic plane, a thin disk filled with stars, gas, and dust, provides the baseline. Perpendicular to that plane, pointing outward from the disk, are the galactic poles. The North Galactic Pole is the point above the disk, and by definition, it lies in the constellation Coma Berenices. To imagine this direction is to picture looking up from our solar system, not up in the sense of standing on Earth and tilting your head, but up relative to the cosmic pancake of the Milky Way. It is a line of sight that carries us out of the crowded galactic plane and into the quiet reaches of intergalactic space. The North Galactic Pole has special significance because of the perspective it provides. When we look along the plane of the galaxy, our vision is filled with billions of stars, gas clouds, and dark dust lanes. The density is overwhelming, and much of what lies beyond is obscured. But when we look toward the pole, the clutter falls away. Instead of trying to peer through the dense heart of the Milky Way, we are gazing perpendicularly through its thin thickness. Within 1,000 light years or so, the majority of the stars in our line of sight thin out, and the view clears. It is as though we have stepped onto a mountain peak above a city of lights, looking into a dark horizon where the sky opens wide. The region of Coma Berenices where the North Galactic Pole lies has long been of interest to astronomers. It is not marked by any especially bright stars, but it points us toward one of the richest deep sky regions of the observable universe. The Coma Cluster, a massive collection of thousands of galaxies, sits in this direction, roughly 320 million light-years away. Through telescopes, these galaxies appear as tiny smudges of light, each one a vast island of billions of stars. To know that we are looking at entire galaxies stacked upon galaxies, layered in depth so immense that light itself has taken hundreds of millions of years to reach us, fills the imagination with awe. From the North Galactic Pole, the universe reveals itself not as a scattered handful of nearby stars, but as a grand architecture, a web of galaxies stretching beyond comprehension. This perspective has been invaluable for cosmology, the study of the universe as a whole. When scientists map the large-scale structure of galaxies, they often choose the North Galactic Pole region because it offers such a clear view beyond the Milky Way. Surveys like the Sloan Digital Sky Survey have traced millions of galaxies in this direction, creating three-dimensional maps of cosmic filaments and voids. These maps show that galaxies are not randomly scattered, but arranged in vast clusters and threads, forming a cosmic web that spans the universe. Each galaxy is like a glowing bead on these filaments, and the spaces in between, the voids, are immense regions of near emptiness. All of this structure is visible most clearly when we look away from the crowded disk and toward the galactic pole. The North Galactic Pole also provides a useful reference for defining galactic coordinates. Just as Earth's latitude and longitude help us navigate the globe, galactic coordinates allow astronomers to map positions in the Milky Way. The equator of this system is the galactic plane, and the poles are its endpoints. The North Pole is set at right ascension 12 hours 51 minutes and declination 27 degrees 7 minutes in the sky, giving astronomers a fixed anchor from which to measure. Without this coordinate system, the Milky Way's orientation would be much harder to describe, and comparisons between observations would be less precise. The clarity of the North Galactic Pole has also been important for studying phenomena beyond galaxies. One example is the cosmic microwave background radiation, the faint afterglow of the Big Bang. This radiation permeates the universe, but to measure it accurately, scientists need to avoid interference from the Milky Way. Looking toward the poles, where the density of stars and gas is lowest, allows for cleaner measurements. Satellites like COBE, WMUP, and Planck have taken advantage of this orientation, using views away from the disk to refine our understanding of the universe's earliest moments. The temperature variations in this radiation, mapped with exquisite precision, reveal clues about the birth of structure in the cosmos and the role of dark matter and dark energy in shaping it. But the North Galactic Pole is not entirely empty. As with any direction in space, there are stars, clouds, and structures scattered along the way. Within a few hundred light years, we encounter nearby stars belonging to the local bubble, the cavity of hot gas in which the sun resides. Beyond that, we may cross faint streams of stars left behind by disrupted dwarf galaxies, relics of collisions that helped build the Milky Way. These streams, though diffuse and hard to see, add texture to the view, reminding us that the galaxy is not static, but shaped by ongoing processes of growth and change. Each stream is like a whisper of the past, a trace of smaller galaxies that once circled independently but have now been absorbed into the Milky Way's halo. The halo itself extends far above the galactic disk, and when we look toward the pole, we are peering through it. This halo is filled not only with ancient stars, but also with dark matter, the invisible substance that outweighs the visible galaxy by a factor of several. The distribution of dark matter is inferred through its gravitational pull, and the motions of stars above the plane provide hints about how it is spread. To gaze toward the North Galactic Pole is therefore to look through one of the key laboratories for understanding the unseen mass of the universe. Without dark matter, galaxies like the Milky Way would not hold together. Their stars would fly apart under the force of rotation, but because dark matter binds them, they remain coherent, spinning like great pinwheels suspended in the void. Culturally, the idea of the North Galactic Pole also has a kind of symbolic weight. It represents ascent, the notion of rising above the crowded, complex layers of the galaxy and seeing beyond. For those on Earth, steeped in traditions of navigation and orientation, north has always been a guide, a marker of direction. The galactic north, though entirely unrelated to Earth's, carries a similar resonance. It reminds us that in the vastness of space, we still seek markers to tell us where we are and where we might look. It transforms the night sky from an endless, overwhelming expanse into something that can be charted, navigated, and known. And yet, for all its utility and significance, the North Galactic Pole is still just a point in an infinite sky. It is a reminder of how much we impose meaning on directions, how we create frameworks to make sense of something boundless. To say, we are looking north, is not to find an ultimate truth about space, but to acknowledge a perspective, a way of orienting ourselves in a cosmos, without inherent up or down. From this perspective, the North Galactic Pole becomes more than an astronomical definition. It becomes an invitation to think about what lies beyond our immediate home, to imagine the universe not as a two-dimensional map of stars, but as a vast, three-dimensional arena filled with structure, history, and mystery. When astronomers speak of the South Galactic Pole, they are referring to the opposite point of the North Galactic Pole, the direction that lies directly beneath the Milky Way's disk. If the North Pole points our gaze toward Coma Berenices and the Coma Cluster, then the South Pole carries our vision toward the constellation Sculptor, a part of the sky that opens into a quieter region of the cosmos. This southern orientation defines what lies below our solar system, beneath the galactic plane, into spaces where the density of stars fades and the view of the wider universe becomes far less obstructed. To imagine the South Galactic Pole is to imagine standing beneath the crowded ceiling of the Milky Way and looking downward into a clearing, where the cosmic scenery stretches away in crisp and unbroken detail. The significance of the South Galactic Pole lies not only in its symmetry with the North, but also in its clarity. The Milky Way, when viewed from Earth, appears as a glowing river of stars across the night sky. Its beauty comes from density, from the layering of billions of stars in our line of sight. But that same beauty is a kind of barrier. The bright clutter of the galactic plane blocks our view of the universe beyond. In the South Galactic Pole, the opposite is true. By looking away from the plane, down through the thin thickness of the disk, the stars fall away more quickly, and the interstellar dust that veils our vision diminishes. The sky here becomes transparent, and the faint whispers of galaxies far beyond the Milky Way come into sight. This is why astronomers so often turn their instruments toward this pole. It gives them a window into the deeper structure of the cosmos. The constellation Sculptor, which hosts the South Galactic Pole, is not bright or easily recognized with the naked eye. It is faint, composed of modest stars. Yet within its borders lies one of the nearest groups of galaxies beyond our local group, the Sculptor group. Among them is NGC 253, the Sculptor galaxy, brilliant starburst galaxy undergoing intense periods of star formation. Through telescopes, it shines as a misty, elongated oval, glowing with the light of billions of stars, many of them newly born. When we look toward the South Galactic Pole, we are not only gazing into the void, We are gazing at one of the most active neighboring galaxies, a reminder that creation is ongoing, that the universe is alive with stellar birth and renewal. The southern galactic pole has been especially important for mapping the large-scale universe. Because the foreground clutter of the Milky Way is minimized in this direction, astronomers can catalog galaxies with less interference. Surveys of this region reveal clusters of galaxies, elongated filaments, and vast voids, the building blocks of the cosmic web. Each faint smudge of light recorded in these surveys represents not just a star but an entire galaxy, often containing hundreds of billions of stars. Taken together, these surveys show the distribution of matter on scales far larger than a single galaxy, scales where the Milky Way is but one strand in a vast cosmic tapestry. Looking into the South Galactic Pole, we gain a sense of perspective. Our galaxy, so immense when considered alone, becomes one of countless others woven into a universe without end. But this southern direction also reveals much about the Milky Way itself. The galactic disk is a thin structure, only about 1,000 light-years thick compared to its immense width. When we look below, we quickly pass out of the crowded plane and into the galactic halo, a vast, spherical envelope surrounding the Milky Way. This halo contains ancient stars, relics of the galaxy's earliest formation, as well as globular clusters, dense, spherical collections of stars that orbit like satellites around the galaxy. These globular clusters, often billions of years old, are fossils of the early universe. They glow faintly in the dark, bound together by gravity, resilient against the passage of cosmic time. To gaze below the solar system is to gaze into this realm of ancient light, where stars older than the sun drift silently through the halo. The halo also preserves evidence of galactic cannibalism. Over billions of years, the Milky Way has consumed smaller galaxies, pulling them apart with its gravity and scattering their stars across the sky. Some of these streams of stars can be traced below the galactic plane, faint rivers that arc across the halo. These stellar streams are the remnants of dwarf galaxies torn apart by tidal forces, their identities erased, but their stars left as lingering trails. Observing them allows astronomers to reconstruct the Milky Way's history, to piece together how it grew, and to understand that our galaxy is not a finished object, but an evolving structure shaped by collisions and mergers. And then there is the presence of dark matter. Though invisible, dark matter makes up most of the galaxy's mass, and its influence extends well beyond the visible disk. The galactic halo, stretching out above and below the plane, is thought to be composed largely of this unseen material. It is what holds the Milky Way together, what prevents the stars in the outer arms from flying away under the force of rotation. Looking toward the South Galactic Pole means looking into this invisible scaffolding, a structure we cannot see, but whose effects shape everything from the motion of stars to the formation of galaxies themselves. The stars and globular clusters we do observe are like light strung along a hidden framework, betraying the outline of something far larger and more mysterious. For astronomers studying the early universe, the South Galactic Pole provides a window of extraordinary clarity. Observations of the cosmic microwave background radiation often focus on directions away from the galactic plane, where interference is minimal. This faint radiation, left over from the Big Bang, encodes information about the earliest conditions of the universe. By looking below the plane, instruments such as the Planck satellite have been able to measure the temperature fluctuations of this radiation with astonishing precision, offering clues about the birth of cosmic structure, the distribution of matter, and the roles of dark matter and dark energy in shaping the universe's fate. Without the clear window of the galactic poles, these delicate measurements would be far more difficult, if not impossible. The South Galactic Pole is also culturally intriguing. While it does not shine with the prominence of Orion or the Big Dipper, its role in science has made it a symbolic counterpart to the North. It represents descent, a direction into quieter, emptier realms. In human imagination, below often carries connotations of foundation, of grounding, of what lies beneath the surface. In the galactic sense, below is not a place of roots, but a place of clarity. It is where the distractions of the Milky Way fall away, and the wider universe reveals itself. In this way, the South Galactic Pole becomes a metaphor for perspective itself, the idea that to truly understand our place, we sometimes need to look beyond the noise, into the clearer spaces where the larger picture comes into focus. Even though these directions, North and South Galactic Poles, are defined by astronomers for convenience, they carry deeper meaning. They show us that even in a universe without inherent up or down, we can still orient ourselves, still find paths through the immensity. By naming these poles, we give ourselves the ability to describe where we are, where we might go, and what we might see. Looking below, toward the South Galactic Pole, is not only a matter of astronomy, but a matter of identity. It tells us that our solar system is not floating randomly in space, but anchored in a grand design, part of a galaxy that has direction, structure, and history. When we talk about above and below our solar system, about the galactic poles and the structure of the Milky Way, it can feel as though the solar system is drifting alone in an endless void, with only vast directions to give it meaning. Yet the truth is gentler and more intimate. The solar system does not float in total isolation. It has a neighborhood, a local environment in the galaxy that surrounds and influences it. Astronomers call this environment the local bubble, and within its boundaries lies a tapestry of stars, gas, and empty space that shapes the quiet region we call home. To understand what is above and below us, in cosmic terms, we must first understand the very bubble we drift through, a structure that protects, defines, and reveals the history of our galactic surroundings. The local bubble is a cavity in the interstellar medium, the tenuous gas and dust that fills the spaces between stars. Unlike the crowded star-forming regions that appear as glowing nebulae, this bubble is largely empty, spanning about 1,000 light-years across. It is not a void in the sense of absolute nothingness. Rather, it is a place where the density of material is far lower than average. Inside the bubble, the gas is hot and thin, heated long ago by the shockwaves of supernova explosions. These violent deaths of massive stars, perhaps 20 or more over millions of years, cleared out the thick interstellar clouds that once occupied this space, carving the cavity in which our solar system now resides. Imagine a series of enormous fireworks detonating in the galaxy's night, each one pushing back the gas and leaving behind a hollow. Together, these overlapping hollows created the local bubble, and by coincidence or fate, our sun drifts inside it today. This environment is not just an astronomical curiosity. It defines what we see when we look out into space. The bubble's low density of dust allows starlight to travel with less obstruction. That is why, even though we live within a galaxy rich with clouds of obscuring material, of our view to nearby stars remains remarkably clear. When you look up on a dark night and trace the brighter stars of Orion or gaze at the twinkling of Sirius, you are looking at neighbors whose light is made visible to you because the bubble between us is relatively transparent. In denser parts of the galaxy, the dust of interstellar clouds dims and reddens starlight, cloaking distant suns. But in our neighborhood, the view is open. The local bubble, in a sense, is a cosmic clearing, a place where the stars are revealed in sharper relief. The solar system does not simply sit at the bubble's center. It moves through it, orbiting around the Milky Way at an astonishing speed of more than 500,000 miles per hour. Alongside us are many other stars, members of what astronomers call the local interstellar cloud, a small pocket of slightly denser gas within the larger bubble. Our sun and its planets are currently drifting through this cloud, which is only about 30 light-years across. This journey through interstellar space is not static. Millions of years from now, the solar system will move into another region of the galaxy, leaving behind this local clearing and entering whatever new environment lies ahead. In that sense, our cosmic neighborhood is not permanent. It is a temporary chapter in the long story of the solar system's travels around the galaxy. The local bubble also gives astronomers a way to understand the past. By studying its structure, they can infer when and where the supernova that created it must have exploded. Some of these explosions may have happened less than 10 million years ago, in a region of space where massive stars once thrived. Their remnants can be traced in the form of expanding shells and subtle X-ray emissions still detectable today. Each supernova would have been bright enough to outshine an entire galaxy for a brief time, flooding the bubble with energy and pushing out the walls of surrounding gas. In this sense, our interstellar neighborhood is like a fossil of ancient cataclysms. We live in the aftermath of cosmic violence, yet what remains for us is peace, a bubble of thin air, quiet and protective, through which our star calmly shines. The walls of the bubble are not uniform. They are like a patchwork quilt, made of denser regions where gas and dust have piled up, forming filaments and clouds. Beyond those walls lie neighboring bubbles, cavities created by other supernova scattered through the galaxy. In fact, the Milky Way is a patchwork of such bubbles, overlapping and intersecting, with stars and planetary systems drifting through them like ships through invisible seas. Our local bubble is only one among many, but it is the one that defines our sky, our immediate window into the cosmos. For astronomers, mapping this environment has become a way of tracing our place in the galaxy with greater precision. Using data from space telescopes like Gaia, scientists have charted the three-dimensional positions of millions of stars, revealing how the bubble surrounds us. In these maps, our solar system appears nestled inside a cavity with curving walls, beyond which new stars are being born. The edges of the bubble are not just static borders. They are regions of active star formation, where compressed gas has given rise to new generations of suns. In this way, the bubble is both a relic of destruction and a cradle of creation. The very explosions that cleared the cavity may have triggered the birth of the stars that line its edges. Continuing the cycle of cosmic renewal, the idea that we live inside such a structure reshapes how we think about above and below in the galaxy. Above, we see the dense fields of stars in the galactic plane. Below, we find clearer, quieter regions. But all of these directions are filtered through the lens of our bubble. The transparency, the clarity, the unobstructed views, they are possible because of this neighborhood we occupy. Without it, our sightlines would be different, our maps of the galaxy less precise, our understanding of the broader universe more clouded. The local bubble is not simply background. It is the stage upon which our observations are made. This neighborhood also plays a role in shielding the solar system from galactic radiation. Cosmic rays, high-energy particles that stream through the galaxy, are partially modulated by the magnetic fields and structures of the interstellar medium. The low-density environment of the bubble changes how these rays flow around us. Combined with the protective influence of the heliosphere, the magnetic bubble created by the solar wind, the local bubble contributes to the conditions that make Earth a habitable place. Life on our planet, in ways subtle and profound, is shaped by the environment beyond our solar system. The calmness of our interstellar neighborhood is part of the balance that allows life to thrive. When we think of neighborhoods, we often imagine streets lined with houses, familiar faces, boundaries that shape our daily experience. The interstellar neighborhood is both stranger and more profound. Its boundaries are light years away, its history measured in millions of years, its scale incomprehensibly vast, and yet it is our home. Just as a neighborhood gives us context, connection, and a sense of belonging, the local bubble situates us in the Milky Way. It reminds us that even in the vastness of the galaxy, we are not without a frame, not without a place that gives meaning to our position. When you picture the Milky Way, you might imagine the graceful spiral arms, their bright arcs sweeping outward from the galactic center, filled with stars, dust, and glowing clouds of gas. The solar system, along with countless others, sits embedded within one of those arms, orbiting in rhythm with the galaxy's rotation. But the Milky Way is not only its disk, not only the bright band of starlight that we see stretching across the night sky. Surrounding this familiar structure is another, far less visible realm, extending above and below the galactic plane. It is called the galactic halo, and it reaches out like a ghostly sphere around the entire Milky Way. To speak of what lies beyond the layers of our galaxy is to speak of this halo. a region where ancient stars drift, globular clusters orbit in slow arcs. An unseen matter holds the galaxy together against the pull of time. The galactic halo is not an object we can see directly, not in the way we see the Milky Way's shining core or the dark lanes of dust threading across the disk. It is faint, diffuse, and sparsely populated. The stars that dwell here are old, so old that they trace back to the earliest days of the galaxy's formation, more than 10 billion years ago. Many of them are metal poor, meaning they lack the heavier elements forged in later generations of stars. Their chemistry marks them as survivors from an age when the universe was young, when hydrogen and helium were nearly all that existed. To gaze at a halo star is to gaze at a relic, a fossil of the universe's childhood, still burning after all these billions of years. Globular clusters are among the most striking features of the halo. These are dense, spherical gatherings of hundreds of thousands of stars, bound tightly together by gravity. From the ground, through even a modest telescope, they appear as shimmering balls of light, their cores so crowded that the stars blur into a single luminous glow. M13 in Hercules, Omega Centauri in the southern sky, these are some of the treasures of the halo. Each cluster is a time capsule, preserving stars that formed together in the distant past, their light carrying whispers of the galaxy's earliest chapters. Orbiting high above and below the galactic plane, globular clusters sweep out long, slow paths around the Milky Way, moving through the halo like lanterns suspended in an invisible sea. But the halo is not only made of stars we can see, it is also the domain of dark matter, the mysterious, invisible substance that outweighs ordinary matter by far. Though we cannot detect dark matter with our eyes or telescopes, we know it must be there. The way stars move in the Milky Way, the way they orbit faster than the visible mass of the galaxy, should allow betrays the presence of this hidden component. Dark matter forms a kind of scaffolding, an unseen skeleton that holds the galaxy together. It extends far beyond the visible disk, surrounding the Milky Way in a vast halo that may stretch hundreds of thousands of light-years in every direction. Above and below the galactic plane, beyond the regions of bright starlight, this dark halo dominates. To think of what lies beyond the layers of our galaxy is to acknowledge that most of it is invisible, its presence revealed only by its gravitational pull. Within the halo are also faint tidal streams, long trails of stars left behind when smaller galaxies fall into the Milky Way's gravitational grasp. Over billions of years, the Milky Way has grown by consuming dwarf galaxies, tearing them apart and scattering their stars across the halo. These stellar streams are like scars, faint evidence of the galaxy's violent past. Some stretch across half the sky, rivers of light only recently mapped by surveys such as Gaia. Each one tells a story, a small galaxy, once whole, now absorbed, its stars captured and folded into the larger body of the Milky Way. Above and below our solar system, within the halo, these ghostly rivers drift silently, their arcs marking the history of cosmic mergers. Beyond the halo of stars, globular clusters, and tidal debris, there lies an even more tenuous realm, the circumgalactic medium. This is a vast, diffuse cloud of gas that surrounds the galaxy, extending far beyond the disk, perhaps as far as half the distance to the Andromeda Galaxy. Invisible to the naked eye, this medium reveals itself in X-ray observations and in the way it absorbs light from distant quasars. It acts as both a reservoir and a recycler, holding the gas that can one day flow back into the galaxy to form new stars, while also collecting the outflows of material driven out by supernova and stellar winds. It is a kind of breathing layer around the Milky Way, sustaining the cycle of matter across cosmic time. Above and below us, in this circumgalactic space, the story of galactic evolution continues quietly. In processes so slow and vast, they stretch far beyond the human scale of time. The existence of the halo also changes how we perceive our place in the galaxy. When you stand on Earth and look up at the Milky Way, it feels like a flat band across the sky, a thin structure you could imagine skimming along the surface of. But in reality, the galaxy is three-dimensional, and the disk is only a fraction of the whole. The halo reveals that our galaxy is not a simple, flat spiral, but a layered, complex object with a structure that extends far above and below. The solar system, in its orbit around the Milky Way, is not only circling the galactic center, but also bobbing slightly up and down, weaving in and out of the disk. Moving through this invisible halo as it journeys through the galaxy, astronomers studying the halo find themselves confronting fundamental questions about the universe. If dark matter dominates the halo, then understanding its shape and density could reveal the very nature of this elusive substance. If tidal streams trace the remains of devoured galaxies, then mapping them tells us how galaxies grow, how the Milky Way itself became what it is today. If the circumgalactic medium acts as a reservoir for gas, then it may explain how galaxies sustain star formation over billions of years. In this way, looking beyond the galaxy's visible layers is not only about seeing what is there, but about answering the deepest questions of cosmic evolution. The halo, though faint, is a place of extremes. The stars within it are some of the oldest known, their ages reaching back to a time not long after the Big Bang. The clusters that drift there are among the densest stellar environments, crowded with hundreds of thousands of suns in volumes small enough to fit inside the space of a few dozen light years. The dark matter that permeates it outweighs all the stars, planets, and gas in the galaxy combined, yet it does not interact with light or with ordinary matter in ways we can easily detect. And the circumgalactic gas that fills the space around it is spread so thin that even a cubic mile of it may contain less matter than a teaspoon of Earth's atmosphere. Yet across millions of light years, it adds up to a reservoir larger than the entire galaxy itself. These are the scales and contrasts that define what lies beyond the Milky Way's layers, above and below our solar system. When we think past the disk and into the halo, we are reminded of how small the part we see truly is. The bright arms of the Milky Way, the glowing lane across the sky, represent only the thinnest slice of the galaxy's true structure. Beyond that, in the dim and hidden halo, lies the majority of its mass, the deeper truth of its history, and the key to its future. The halo is not an afterthought or a border. It is the framework. It is what gives the Milky Way its integrity, what holds it together across cosmic time, what connects it to the web of galaxies stretched across the universe. When we ask what lies above and below our solar system, when we speak of galactic poles, of halos and bubbles, of the structures that rise beyond the Milky Way's luminous disk, we are really circling a deeper truth. The truth is that these directions above, below, north, south, are human inventions. They help us navigate, help us imagine where we stand in relation to the galaxy. Yet, in the vastness of space, there is no universal up or down, no preferred orientation. What matters is perspective, the way our minds shape infinity into something we can hold, the way our imaginations allow us to place ourselves within a cosmos that does not provide natural borders. To explore the cosmic perspective is to step back, to understand not only the structures around us, but the meanings we attach to them. The solar system is a speck, orbiting a single star on the edge of a spiral arm. From here on Earth, we feel central. The sun rises, the planets circle, the stars will across the night sky. Our senses anchor us to this place, as if it were the pivot point of existence. But from another vantage, say, from a planet orbiting a star in the Andromeda galaxy, we are invisible, insignificant. Above and below vanish in that view, replaced by the quiet knowledge that the Milky Way itself is just one galaxy among 2 trillion others that stretch across the observable universe. The cosmic perspective reminds us that scale reshapes meaning. What is vast from one view is minute from another. What feels like a whole sky to us is a small patch of starlight to someone else. Yet insignificance is not the whole lesson. Perspective does not erase value. It reframes it. To be small is not to be meaningless. When you look up at the Milky Way, when you follow the line of stars that marks the galactic plane, you are looking not only at countless suns, but at the architecture of creation itself. Above and below are directions that give us structure. They allow us to map, to explore, to know. They are tools, not truths. but they anchor us. Without such frameworks, the cosmos would be too vast to comprehend. Perspective allows us to make sense of infinity without diminishing it. Think of the local bubble, the cavity of hot, thin gas carved out by ancient supernova. Within it, our solar system drifts like a ship in calm waters. To one perspective, this is chance, a coincidence of galactic geography. To another, it is a reminder of history, the deaths of stars making way for the clarity through which we now see. Above the bubble lies the galactic plane. Below it stretches the halo. But more than that, the bubble itself becomes a metaphor for how perspective works. It is not a permanent feature. It is transient. In time, the sun will leave it behind, moving into another region, another environment, and what feels like our neighborhood will shift. The cosmic perspective tells us that even the frames we use to understand space are impermanent, shaped by movement, by time, by evolution on scales far beyond our lifetimes. Above us, toward the North Galactic Pole, the dense star fields of Coma Berenices shine, and beyond them, the distant clusters of galaxies fill the void. Below us, toward Sculptor, the sky clears, and the wider universe opens with less obstruction. To say above and below is to borrow language from the Earth, where gravity defines orientation, but in space, every observer has their own up and down. For someone on a world orbiting a star near the galactic center, the directions reverse. For another drifting in the halo, the Milky Way itself becomes a thin band below their horizon. The cosmic perspective requires humility, the recognition that the universe does not conform to our instincts. It allows us to use orientation as a tool while knowing it is relative, not absolute. Beyond orientation, perspective also shapes how we think about time. The stars in the halo are ancient, 10 billion years old, nearly as old as the universe itself. The clusters orbiting far above and below the disk are fossils, survivors of an era when galaxies were just beginning to take shape. To see them is to look backward, to glimpse epochs so distant that our own species, our own planet, had not even formed. Perspective reveals that we are late arrivals, appearing only in the final moments of a cosmic story that stretches for billions of years. And yet, in the blink of our existence, we have reached out with thought and mathematics, with telescopes and spacecraft, to begin to comprehend this story. The cosmic perspective reveals not only our lateness, but our ability, against the odds, to understand. And what of the unseen? Dark matter, which forms the framework of the halo, outweighs all visible stars, yet it is invisible to us. Dark energy, which drives the acceleration of the universe's expansion, shapes the cosmos on scales so large we cannot yet grasp them. Above and below, inward in every direction, the majority of existence is hidden. The cosmic perspective demands that we live with mystery, that we accept that our view is partial, that our maps are incomplete, that our knowledge is still a fragile beginning. It asks us to wonder not only at what we know, but at the immensity of what we do not. And still, perspective is not only about scale or ignorance. It is also about beauty. To step outside under a dark sky, far from city lights, and see the Milky Way arching overhead, is to feel a connection that transcends the limits of science. The knowledge of where we are, of what lies above and below, enhances that beauty rather than diminishes it. To know that the band of light is our galactic plane, to know that the halo extends beyond it, to know that clusters and streams and invisible matter stretch in every direction, this knowledge deepens the awe, it sharpens the wonder. Perspective does not replace mystery with facts. It weaves them together. Even the simplest observation, the idea of looking up or down, carries resonance. On Earth, up has always been the direction of transcendence, of aspiration, of heaven. Down has often been the direction of foundation, of grounding, of the unseen depths. In the cosmic perspective, these symbols are not erased, but transformed. Up becomes the crowded lanes of stars. Down becomes the quieter windows into deep space. Both directions reveal truth. Both carry meaning. The human mind seeks orientation because it seeks understanding. The cosmos does not offer it freely, but through perspective, we build it. As we drift back from this long journey above and below our solar system, we return with something more than facts and discoveries. We return with perspective. We have looked upward into the crowded galactic plane, where countless stars weave the Milky Way into a glowing ribbon of light. We have looked downward into the quieter windows, where the deep universe reveals itself in clusters and voids that stretch across unimaginable distances. We have traced the boundaries of the local bubble, wandered into the galactic halo, and even brushed against the mysteries of dark matter and dark energy. Each direction has shown us not only what exists, but how fragile and extraordinary our place within it truly is. In the vastness of the cosmos, the solar system is small, yet it is our home, a warm island in a boundless ocean. The truth is that above and below are not fixed. They are tools we use to orient ourselves, to imagine where we stand in relation to something far greater. In that sense, these directions are less about navigation and more about meaning. They remind us that, wherever we look, there is always more to discover, more to wonder about, more to inspire us. For an audience here in the United States, or anywhere on Earth, this exploration connects us to something universal. When we gaze at the night sky, we are all looking from the same small world, turning together around the same star. Whether we speak of above or below, inward or outward, we share the same journey, the same questions, the same wonder. The universe does not single out one place as central or preferred. It reminds us that every perspective is valid, every vantage reveals something true, and together, they create a mosaic of understanding. And so, what lies above and below our solar system is not only a map of stars, gas, and galaxies. It is a reminder that we are part of an unfolding story, written in light and shadow, in movement and silence, in time that stretches back billions of years and forward into futures we cannot yet see. To know even a fraction of this story is to feel both humbled and elevated, both grounded and uplifted. It is to recognize that while we are small, we are also capable of asking, of wondering, of reaching. In the end, the directions above and below are invitations. Invitations to look farther, to think deeper, to dream wider. Invitations to rest, knowing that the universe holds us in its vast embrace. And as you close your eyes and let these thoughts settle, remember, in the quiet of the night sky, every star, every cluster, every unseen halo whispers the same truth: that we are here, that we are part of this, and that the cosmos, in all its mystery, is also home.